How to define system boundaries in thermodynamics. Have you ever wondered how we determine what is inside a system and what is outside in thermodynamics? Understanding system boundaries is key to grasping the first law of thermodynamics. Let's break it down together. In thermodynamics, a system boundary is the line that separates the system from its surroundings. The system is the part of the universe we are studying, while everything outside is considered the surroundings. This boundary can be a physical wall, like the walls of a container, or it can be an imaginary line drawn for analysis. To define these boundaries, start by considering the purpose of your analysis. What do you want to study? The boundary should enclose the area where you will track energy and mass exchanges. There are different types of boundaries to consider. A boundary can be physical or imaginary. For example, a real wall of a container is a physical boundary, while an abstract surface in space is imaginary. Boundaries can also be rigid or flexible. Rigid boundaries are fixed in shape and volume, like a sealed jar, while flexible boundaries can change shape, such as a piston in a cylinder. Another important aspect is whether the boundary is permeable or impermeable. A permeable boundary allows mass to cross, while an impermeable boundary prevents mass transfer. For instance, a sealed bottle is impermeable to mass but may allow heat transfer. Now, let's classify systems based on their boundaries. A closed system does not allow mass to cross the boundary, but energy can move in and out. An example of this is a sealed container. In contrast, an open system allows both mass and energy to cross the boundary, like an open cup of coffee. Finally, an isolated system does not allow either mass or energy to cross its boundary, ideally being completely insulated. The interaction across the boundary is essential. It controls how heat, work, and mass transfer between the system and surroundings. When applying the first law of thermodynamics, which focuses on energy conservation, the boundary defines where energy enters or leaves the system. Defining system boundaries is not just about drawing lines. It means clearly specifying what is inside your system and what is outside. You need to decide if and how matter and energy can cross the boundary, and whether the boundary is fixed or movable. This clarity is vital for applying thermodynamic principles and solving energy transfer problems. In practical terms, when you define your system boundaries, you set the limits for energy and mass accounting. This is crucial when applying thermodynamic laws like the first law. For example, in a piston-cylinder device, the movable piston forms part of the boundary that allows work transfer as the piston moves. By understanding how to define system boundaries, you can better apply the first law of thermodynamics and grasp the fundamentals of thermodynamics.